So now we see a number inside the function with the x. From chapter 3, we know that this would be a horizontal compression. You would multiply your x values by 1/6. So it says, in the question says determine the period of each function. We're going to graph it as well, because the one thing that we want to get good at in this unit is graphing these. So now, horizontally, normally we drew our axis family, and we drew one period to 2 pi. Now, instead of having 2 pi, because I'm multiplying my x values by 1/6, my 2 pi is going to change to, well, I can write it as 2 pi over 6. I could reduce that to pi over 3 if I wanted to. Can you see that that's taking 2 pi and multiplying it by 1/6? Now your axis family always divided 2 pi into 4 equal sections. But instead of multiplying them all by pi at 1/6, what I like to do is I say, okay, if this is 2 pi over 6, the middle one's going to be half of that. What's half of 2 pi over 6? Pi over 6. And then the first one is going to be half of pi over 6. What's half of pi over 6? Pi over 12, just multiplying by 1/2. And then for the third one, I like to count. Well, if they're all equal, and this is 1 pi over 12, this would be 2 pi over 12, this would be 3 pi over 12. And again, you could reduce that to pi over 4 if you wanted to, but you could leave it like that. And since it's horizontal, my y values don't change, so my maximum is still 1, my minimum is still -1, my center line is still at y equals 0. Where does a coast graph start? At a maximum. So we start at our maximum, next axis family, center line, then minimum, then center line, then maximum. So we're already sort of developing a shortcut because we're not doing this point changes to this point like we did in chapter 3. And in this question, we could say that our period is 2 pi over 6, or if you wanted to reduce that, you could write it as pi over 3. Okay, part B. Part B was y equals tan of 2/3 x. This is going to be a horizontal stretch. You're going to multiply your y values by 3 over 2, the reciprocal. Now, our tan graph originally had non-permissible value here, non-permissible value here, another non-permissible value, and a bunch of them continuing. I'll just do these 3. This one's equation was at pi over 2, right? But now we're going to multiply all of our x things by 3 over 2. So it gets multiplied by 3 over 2. Can you see that its equation is going to become 3 pi over 4? Same thing with the one at negative pi over 2. When I multiply by 3 over 2, it's going to become negative 3 pi over 4. The next one would become positive 9 pi over 4. What's the shape of our tan graph? The shape of our tan graph stays the same. Now, what's our period of our tan graph? Well, It repeats itself from one asymptote to the next. How much of a distance is it between those two asymptotes? Three pi over 4 plus 3 pi over 4? Does that make sense? Because this one's at negative 3 pi over 4, so it'd be 3 pi over 4 to 0 plus another 3 pi over 4 to the next one. If you added those together, you would get 6 pi over 4, or you could reduce it to 3 pi over 2. Now, if we think about the fact that the period of just your regular tan graph, which goes one asymptote at negative pi over 2, the other one at pi over 2, the period of a regular tan graph is pi. And now we've stretched it by 3 over 2. Does it make sense that your new period would be 3 over 2 pi? If you look at your first question, the period of a regular cos graph is 2 pi. You've compressed it by 1/6. Does it make sense that your new period is 2 pi over 6? And when we go to part C here, you may want to rewrite this as sine of 1/7 x, so that it becomes really obvious that you have a horizontal stretch. You're going to multiply your x values by 7. When I go to graph it, what am I going to write instead of 2 pi? 14 pi. And then divide it into 4 equal sections. What's the one in the middle going to be? 7 pi. This one, cut it in half. 7 pi over 2. And if you count 1 7 pi over 2, 2 7 pi over 2s, 3 7 pi over 2s, 3 7s is 21, so we get 21 pi over 2. Y values don't change, so our maximum and minimum are still 1 and negative 1. Our center line is still at y equals 0. Where does the sine graph start? On the center line, going up. So start on your center line, go up, and back to center line, down to minimum, back to center line. And we can say that our period is 14 pi. So our horizontal stretches and compressions change our period. Makes sense, because you're stretching and compressing it horizontally. Your period that was 2 pi for sine and cos, or your period that was pi for tan, are going to get changed. At the bottom of your page, at the bottom of your page, there's a box that says the period of a trig function, and they have some formulas here. I'd like you to rewrite those formulas underneath. Whenever you have, and we call it a b value, because whatever's in front we're going to call the a value. Whenever you have a horizontal stretch or compression for sine or cos, you would divide by your b value to find your new period. Because if the b value is 2, well, that's a horizontal compression by a half. Putting that b value on the bottom is doing the reciprocal. And since the period for tan is just pi, the period for tan, if you had a number in there, would be pi divided by the b value. So these formulas we actually use quite a bit to find the period. And In the green boxes here, I've just rearranged those formulas to solve for the b value because we're also going to be given graphs and have to find the original equation, work backwards. So then sometimes you have to find the b value when you know the period. Sometimes you have to find the period when you know the b value. So both of those formulas are the same, just rearranged of each other. Okay, questions for practice now are C and D of number 3.